Today, instead of heat sinks, of which we still have 2 more to look at from Pablo, which is going to be another video, we've got a little surprise. This is a treat. We're going to look at an M.2 NVMe drive from Gigabyte, but this is not from Gigabyte. This is from Joey, one of our subscribers. So I want to thank you, Joey. And by the way, welcome. This is Builder By. My name's Gil Boyd. I'm your host. Thanks for joining us. Let's open this up and let's see what Joey sent. Now, I want to preface this. This is probably one of 2 possible drives, and if this is what I think it is, this is something I had hoped to look at, but I wanted to take this in a different direction before we got this far. But since Joey offered, I said absolutely, because I think it's relevant, and I think you'll understand when you see the drive. Now, we plan on testing this in 2 locations. On the Supermicro dual M.2 NVMe adapter, and also on the motherboard in the 2nd position, and I'll get to the system specs when we get there. But I think what we're going to find is something that's kind of been in the works with the vendors, and I say that because I think it'll become self-evident. What we've been looking at with heat sinks is a solution to an old problem. Because of the heat, we've got to look at this in a little bit different way. And if this is the drive I think it is, this may be one that's appropriate for some of you looking at other equipment besides a computer. I'll get into that in a minute too. Let's see what we've got here. Joey said I'd like for you to take a look at this drive and test it and tell me what you think. So if anybody else has something they'd like for us to test, these are things we used to do at the live meeting, but I'll be happy to. In fact, I've got some information I want to share with you about the Seagate FireCuda 530. We'll do that in a separate video. Aha. Okay. This is what I call a shadow of things to come. Now this particular drive is PCI-Express 4.0, and we're going to take a look at the specs. I'm going to pull that up, but what I want to describe to you as we look at this and examine it, we've got our notch on one end, if you'll take here on the left side where it's been machined, and we have an M.2 NVMe drive already encased in a heatsink, and it says thermal design for generation 4. And if you'll notice, we've got 3 screws on each side. And looking at the way this is designed, because this is already encased, this has a thermal pad on the bottom, and we're going to need to put a thermal pad on the top. Now this enclosure normally comes with the drive mounted in it, but we're going to get to look at how well this heatsink performs. This is the heatsink that Gigabyte uses on, again to reiterate, PCI-Express 4.0 first generation. Now the 2nd generation drives use an aluminum heatsink, and they have a nanocarbon fiber coating technology on them. So this drive that would have been in this housing would have been 5,000 megabytes. So what we're going to do, we're going to take WD Black SN850, which is PCI-Express 4.0 2nd generation, so it's capable of 7,000 megabytes. And we're going to see how it performs in this housing. So the thermal pad we will probably use on this will be a Thermal Grizzly. This should be fascinating. Thank you for Joey for letting us test this heatsink. This also means that the previous heatsink that we had installed that I didn't really care for, we're going to need to take it off, and that's the EKWB. And hold that thought on EKWB, because even though I don't like this particular heatsink, there's another heatsink that they're working on that's sort of out. Well, just hold that thought. I got some more stuff I want to share with you about EKWB. But to reiterate, this one I'm just not fond of. And we're going to get to pull those clips off. We're going to see how that's going to happen, so we can change heat sinks and see how this performs. Okay, keep in mind, I'll bring up the chart in a minute, the WD Black SN850 bare on this card, and this is the Supermicro dual M.2 NVMe adapter in the primary position. To reiterate, the WD Black SN850 came in bare at 92 degrees. And with this last heatsink, we tested it twice. With this heatsink on this card at 60 degrees, and with this heatsink on this M.2 NVMe drive in the 2nd position on the motherboard, it came in at 67 degrees. So we're going to look and see what kind of parameters we have. Another question came up from another subscriber that dealt with what are the operating parameter temperatures for one of these drives. That's a good question. Bent needle nose pliers, so we can pull the push pin, remove the drive, and this is the part that I have not been looking forward to. I've got to take those clips and I've got to pull those clips up and off. And let's see how that's going to work. Now, it may be kind of hard to see this as I do this. Well, that slipped off real easy. I've been really worried about that. With the bent needle nose pliers, just grab it and pull, and right off it came. That blows my mind. I've been really worried about the drive. Another subscriber had commented too that he didn't like the tension that was required. He's afraid he's going to pop the memory on the NVMe M.2 drive. Okay. Well, not to be repeated, I do not want to install that on another drive, period, ever. But even though I don't care for this particular heatsink from EKWB, there's another one they've got that I expect is going to do a whole lot better. And again, I'm kind of teasing you with that, but I want to save it until we get to that. I may give you a little taste of it at the end. So we've got to pull this apart. Came off pretty easy. Boy, that really got some compression. Wow. Now I pointed out where this little button was at right here at the top, and I'll roll that back over, which is this button, but the glue that holds that on. Okay, you can see the indentation, and I'm going to tilt this up a little bit. We had, and you can see the shadow. Let me roll that. I'm not sure which way that's going to roll best. There we go. Okay. Now you can see the indentation of how that all fit together. That compressed quite a bit. Those are the pads that came with the EKWB heatsink. Fascinating. Picture's worth 1,000 words. I will gingerly peel those pads off. One-time use. Now for the bottom thermal pad. Find me a spot where I can get in there. Just a tad bit of leverage. There we go. Okay. And of course the thermal pad stays stuck to the M.2 drive. Okay. We are done with the this particular EKWB. Not to be repeated. And we're going to need a micro screwdriver. And that is a Phillips. And I'm going to use one that is magnetized. This came out of one of the other kits. Those tiny little screws, we don't want those to get away from us. Now this probably has, that may be a 1mm pad on the bottom. I'm not sure. Even though that says, and it's curious, thermal design for generation 4, that's actually for PCI-Express 4.0 first generation. Just want to point that out. It's got some weight to it. It's all copper. I think the point of this to get from this is a heatsink that you're going to be seeing, I think, more of on the higher performance drive, meaning PCI-Express 4.0 second generation and above. Because remember, we got to be thinking about PCI-Express 5, where we're looking at, instead of 7,000 megabytes, drives that are at 15,000 megabytes. So that's a big deal. The question is, how our vendor is going to take care of that. So what I want to do is show you 3 different versions of the way Gigabyte is dealing with this. I'm going to also show you a link into Gigabyte's SSD stuff, which is a little bit confusing. And I'll show you a link also into Newegg that shows what Gigabyte has done with heat pipe technology, just to see a shadow of things of what's going on. Remember, this is designed for 5,000 megabytes. So we're going to put a second generation drive that's 7,000 megabytes. And we're going to see what kind of performance we get. And the parameters we're looking at with the WD Black SN850 at 92 degrees and on the motherboard heatsink at 65 degrees. And of course, all the other stuff we've got, and I've got to update the chart for the last one, which is actually number 10, but on the chart numbering it'd be number 13, and that's what we had with the EKWB. We'll reference that again in a minute. It's always good to think, look, because a lot of this stuff we're doing, you got to zoom in and zoom out. And I got to tell you right now, even though we've got 2 more heat sinks to look at from Pablo, some of this stuff kind of borders on the bizarre. And because of other equipment, not just computers that use an M.2 NVMe drive, we've got to have something that's compact, something that's very succinct, that will fit in a tight place, that can dissipate heat. Our number one thing is about a computer. We're looking inside this computer, that I'll get to the specs in a minute. But some of you that are using one of the PS devices, I'll get into that in a minute too. That's where smaller is better. And these are supposed to be for when we test the top 3. But since this was presented to us by Joey, we're going to have to go ahead and use them now. And remember, the heat sink that came from Thermal Grizzly, even though it was using the Thermal Grizzly pads, Did not perform too well. In fact, that was number 12 on the list. Let's look at that. 68 degrees. Yeah, that was kind of a bummer. And that 68 degrees was using thermal grizzly pads. So it is what it is. These look like Band-Aids. We'll do the 4 things we always do: the unboxing, the inspection, the test, the verification. And once we've done the test, we're going to do the test again twice on the M.2 card and, to reiterate, on the motherboard. I'll get to the motherboard in a minute. Let's pull a Band-Aid out of here. It looks like we've got 2. Yeah, only 2. Wow, these are like a ribbon. These are long. These are like 120 millimeter. So that's a thermal grizzly minus pad 8. Okay, let's get this opened. I'll try to keep this zoomed in as tight as I can, and to remind everyone, if the camera goes in and out of focus because it's looking for something to look at, I keep it on autofocus because sometimes we change the point of attention. That's quite a heat sink. Copper base, and I like that, so we'll have compression. I'm wondering about the bottom pad. I'd kind of like to change it out, because if we're going to do this, I'll just have to get some more thermal pads. Yeah, I think that's appropriate. And this will help us to see where we need to make our cut. I'm using scissors this time to cut. It's easier. Let's see how close I got. Pretty good. Yep, I think that'll work. So Joey, I hope you don't mind, but I think I'm going to go ahead. We're going to do this. I'm going to do both pads. The thermal conductivity of the Thermal Grizzly minus pad, the minus pad 8, means it's 8 W over MK. We've talked about that before, so I won't go into that again. But that's a good number to rate by. And yes, we do have another pad that has a higher rating that we may try. That's part of what we were after to do this. But I think after we zoom out, the takeaway from this is going to be, you're going to be looking for drives that have a cooling solution already on them, instead of buying a bare drive, because you want something that can go on the motherboard. And that's our third location. Our primary is on a dual M.2 NVMe adapter. Our secondary is on a quad card that doesn't have a cooling solution that should. And our third is the motherboard, which this is designed for that, as well as the other equipment I'll get to when we get to that. So I hope you don't mind, Joey, but this is going to have a Thermal Grizzly pad on the bottom. I rolled it just a bit. That laid in there nice and neat. Pull the top off. It's interesting, this copper base, you'll notice, has a lip on it. So when that memory goes in there, it'll fit right up against that lip, which is different than the cooler we had from Sabrent, which had the lip right around the hole here in the enclosure. I just want to point that out. I think this is a smarter idea because we push this up against it, it'll zero out to that point. So let's grab the drive. In we go. And also, I need to point out right now, the holes, the way they've been stamped, they have a little bit of a indentation from the outside in, to allow for the screws. Get one of those there, you can see it. But it puts an indentation on the inside, so this width, side to side, is real crucial. It's very tight. So close and tight that I've got to slide the memory in there. I can't put it in from the top because I've got to get underneath those holes. That's how tight it is. Drop it in, and it just drops right down to the bottom, and it's butted right up there. Man, that's the slickest mount I've had yet. And on the rear end, I say the rear end where the connector's at, we're sticking out not even a 64th of an inch back here. But we clear the connector, that's the point. And from the left side, we are 0 because of this lip right here with this copper that sticks up. And I had to drop it in underneath those screw holes, because if I tried to drop it in from the top, I didn't want to bend it and it wouldn't fit. So I had to slide it in. Slide it in, keep it up, and I did it from the end, let gravity push it in, drop it right down in, perfect. But I wanted to point that out, because anybody else that might do this, I want to keep it simple. So now let's get our top mounted. And the top, yeah, that's going to be good to go. So all we need to do now, you notice I didn't dry fit that. I put that pad in, slid that memory in. This has got to be one of the easiest I've worked with yet. But what I want to do is, again, get an idea of the length of my pad. And we want to cover from memory to controller. That's all. And I cut that bottom, I cut the bottom pad to fit the copper base, but I cut the top pad about not quite an 1/8 of an inch shorter, because I only need to cover, to reiterate, the controller, which is right about here, to the memory, which is right about here. And yes, the label stays, otherwise if I took it off, I wouldn't know who's on first. And yes, it would improve heat dissipation. So reversing the process, I'll peel the pad, roll it slightly, and this time I'm going to turn it around because my crucial end is where the controller's at, and I'm going to drop that on and then just let that drop wherever it drops. Perfect. Spin it back around and gingerly peel that top off. This is the only one I did not dry fit, and that I find very interesting. Okay, now for the top heatsink. That's heavy, copper, and that drops right in between, right down. We have our sandwich, and we can do nothing about compression because the height of those holes are not elongated. In other words, it's just sitting there. There's no compression. So I'm disappointed in that. I'd like to have elongated holes so I could push that down a little bit. But it is what it is. It's still copper. It's a wraparound, which is what we like. And it's got thermal grizzly minus pads at a value of 8 W/MK. So for a one-time test, this ought to be interesting. Actually, considering two locations. So let's reassemble. In case anybody's wondering, the thermal pads we use are 1mm. So that's a 1mm top and a 1mm bottom. And the memory we're using, which is the WD Black SN850, is single-sided. The Samsung 980 Pro that's also on the same card is also single-sided. And all I'm going to do is get the holes lined up with the screws and get them started. I will not drive them home. In other words, I will not drive them all the way in until I'm satisfied I have them all started. But no compression. It's just sitting there. But everything lines up pretty good. But I would have preferred elongated holes. Okay, all three screws are in. So now we'll go ahead and get them all secure. I'm really curious to see how this is going to perform. Now the machine has been off, so we're going to be a cold boot. And that's interesting. An Aorus heatsink that you cannot buy by itself, mounted on a WD Black SN850. Fits perfect on that card. All we have to do now is drop in the escutcheon pin, and we're set. Let's roll it over and take a look. Yes, we're clear on components. That one item that's on the PCB, we are clear. Now we can take the next step. In we go. Definitely adds some weight to the card, I can tell you that. That heatsink shows up well on camera. Okay, the test platform. This is the Gigabyte TRX40 Designare, where we have two 16-lane slots and two 8-lane slots. And we have, in the first 8-lane slot, the Supermicro dual M.2 NVMe adapter with the WD Black SN850 in the top position, and that now has the Gigabyte copper heatsink. And in the second position, remember this card requires, because there's two drives, requires 4 lanes for each drive. So in the second position, we have the Samsung 980 Pro that does not have anything on it. Now, because this has already been bifurcated in the BIOS, we don't need to go to the BIOS. So when we get to that point, we'll go straight into Windows. We'll do our test. We'll show our smart telemetry on the left, and then on the right, we'll have our speed. And we should see 7,000 megabytes. And when we get to the second number on the right, that's when we'll have our hottest temperature as we watch the telemetry on that thermistor. Okay, card is in, secure, plugged in, turned on, energized, power. We have video, as you can see here, coming on. We have an EVGA GeForce RTX 2080 Ti, which is 2 slots wide, in the second 16-lane slot. The primary 16-lane slot, we have a quad card. And in the second 8-lane slot, of which we're only using 4 lanes because we lose 4, we have the Gigabyte Titan Ridge Thunderbolt 3 card. So we have power we can see the BIOS codes, and we also have a PC speaker for post over here where I'm pointing to that you can't see. And to reiterate, once we get past post, we'll go into Windows, and we'll test the drive with that heatsink on it. Thanks, Joey. And remember the temperatures we're looking at, the WD Black SN850 at 92 degrees, and on the motherboard, the second spot on the TRX40 Designare, the second heatsink, was 65 degrees. That's kind of our parameters. And there are some other numbers I'm going to share with you as it relates to drives and the specs, because I want to look at the drive that's supposed to be in that heatsink, and I want to talk about that temperature as it relates to these temperatures. So let's see what we get, see where we go. All right, hardware info, 64. We're going to run sensors only. And we're looking at drive telemetry for the WD Black SN850. There's a Seagate FireCuda 520. And we cannot get a 530 yet, but I've got some information I'll share with you in the next video about that. And right there, that's the WD Black SN850, and that's the Samsung 980 Pro. We're going to be watching these temperatures for the current minimum, maximum, and average. Now right now, our minimum was 34 degrees, so now we're going to bring up Crystal Disk Mark And we already know that happens to be the D drive. It's a 1 terabyte drive, so we have a 1 gigabyte test file. We're going to do all. First number we'll see will be 7,000 megabytes. We're going to focus over here on heat, so I've highlighted that. We'll achieve our 7,000 megabytes. And then when we get to the second number on the right, then we will achieve our hottest temperature on that drive with that heat sink. Anybody want to take bets? Remember, our heat pipes have done the best. The Sabrent Rocket 3 heat pipe at 54 degrees, the Acidity 4 heat pipe at 48 degrees. Right now we're at 46. I'd love to zoom in on that, but I don't want to change the focus. I want us to be able to see all the information at the same time. And even though we're looking at writes per megabyte, what we're watching for is when that hits the hottest point. Now keep in mind, running this test one time is a bit skewed, but to keep it simple with all we've done, that's the way this needs to be done. If we were to do more than just burst mode, if we wanted actual throughput, then a simulation of that could be done one of two ways. One, run this test 3 times. We'll increase that temperature. My guess would be 10 to 15 degrees. Number 2, a file of a specified size that has to run for a specified amount of time. Copy that from drive A to drive B, and then copy that from drive B to drive A, but a different file so that it's not in the cache. And for those wondering, I still hear the MOSFET fan on the motherboard running as it whines in and out. And for those wanting to know about the humidity and the temperature, while we're reading these numbers, we're 45% humidity and 82 degrees Fahrenheit. So you can extrapolate that for the Celsius. So far we've hit 56 degrees. Wow. 57 degrees. Now you have to remember, for those of you who want to run this, I know we always say test and verify, your results may vary. You have to remember, we're on a high performance or a high-end desktop computer, which is the TRX 40 chipset. So if you're on an X570 chipset, you may have different numbers, different results. 2 things you want to remember about a computer. Number 1, the motherboard is the foundation of the computer. Number 2, which is the most important, the chipset is the foundation of the motherboard. The chipset is what you need to focus on when you're building a computer. It's all about resources. As one of our subscribers pointed out, what we do chasing PCI-Express resources now is like we dealt with 20 years ago chasing IRQs, which I thought was a good comparison. Okay, test is complete. We topped out at 57 degrees. I'm blown away. I'm fascinated by that. Let's look at the chart again. Okay, 92 degrees bare, 65 degrees on the motherboard with the second heat sink, and at 65 degrees, and this tested out at 57. Wow. Let's think about that just a second. First of all, this drive is PCI-Express 4, 2nd generation. This heatsink comes on drives that are PCI-Express 4, 1st generation. Now Gigabyte, on their 2nd generation drives, have gone to a different technology where they're using an aluminum enclosure that has a nanocarbon technology on it for cooling. I'd love to test one of those, so if anybody's interested, let me know. But you're going to have to supply it. So the numbers we got, this is test number 1. 57 degrees. So we started out at 34. I think I've seen the lowest on this at 33, starting from a cold boot. But 34 is fine. But 57 degrees. Wow. Let's look at that chart again. The Sabrent Rocket 3 heat pipe was 54. That thing is huge. The Acidity 4 pipe is 48 degrees. It's still big. And this comes in at 57 degrees. And that'll fit just about anywhere. Yeah. Now, if Gigabyte would sell that by itself, and remember, we've also got those thermal pads on there, which are the Thermal Grizzly minus pad. There's 2 of them in there. The Thermal Grizzly minus pad 8, which is 8 W over MK, makes that easy. And the highest I have seen, I believe, was about a 12.8 or a 13 W over MK. So that's something I want to find out if it'll do any better. But with this, with those pads, with that cooler, wow. If Gigabyte would just make that available. Gigabyte at one time did have an optional motherboard heatsink made of aluminum. It's not available anymore. And I may be able to dig one up and find one around here. We got it a long time ago. I think it came out around the time of the X399 chipsets. But this, I wish they'd make that available now. Okay, test number 1. Let's do test number 2 while I let that sink in. All right. Blows your mind. Does mine. Power down. I'm eager to see the results now on the motherboard. How about you guys? Power off. Drained. Perfect. Pull the cord. Now we'll pull the card. Because it's so tight in there to get my nimble fingers, I have to pull the video card to put this on the motherboard. But what we found out was that we can use that double screw together to go down on top. You don't have to separate it and go between the heatsink, which is nice. That double screw on the heatsinks is just, that's crazy. Okay, we'll pull our push pin, pull the drive, set all that aside. And while we run test number 2, we'll leave the Supermicro card out, but we've got to pull the video card to get that heatsink out so we can put that drive in. It's just too tight. And that takes a number 1 Phillips. And I have to use my 4.5 millimeter wrench to get that other part of the screw off so I can put the two halves together. I look at that and I wonder what was Gigabyte thinking when they did that. Someone had entirely too much spare time on their hands, I think. So we'll put these two halves back together, and that'll go down as one screw. Okay, motherboard heatsink is removed. Well, I like the way that fits on there. You can feel it when it drops. Yep, I like that. We'll get the video card back in. And yes, that heatsink sets up, but it does not interfere with the I/O cards, and it's pretty close to that aluminum. It may set up just a tad higher, but it's not in the way, and it wouldn't be under the way even if it was under the primary where this card is at. There's still space right there. It's got room for it. Good to know. Okay, video card is secure. We'll get the video plugged back in, power plugged back in. Card is secure, drive is secure. Always whenever you're monkeying with a computer, always do a mental check to make sure you've got everything set. And we can turn it on and energize. Away we go. Powering up, we see video display coming up. We've got the postcodes on the motherboard, and we'll have a PC speaker that will announce power on self-test. And from that, we can bypass the BIOS. We're going straight into Windows. That will still be drive D, but I'll double check it just in case, because there is a label on the drive to tell me where it's at. So we're not doing this. Windows flag E, this PC, WD Black SN850 drive D, drive telemetry, hardware info 64, sensors only, and we're looking for smart drive telemetry on the WD Black SN850, which would be right there. There's the Seagate FireCuda 520, and since we don't have the Supermicro card in, we don't have telemetry on the Samsung 980 Pro. This is the drive we want to focus on. So we're starting out at 44 degrees. Current, minimum, maximum, and average. Let's bring up Crystal Disk Mark. We know we're D drive, a 1 terabyte drive with a 1 gigabyte test file, all. We'll highlight hardware info so we can read those temperatures in blue. Now let's see where we go. I think it's safe to say or to reiterate that Thermal Grizzly makes some great thermal pads, and Gigabyte makes a great copper heatsink. Once this test is complete, while we're waiting on the numbers, I will bring up the information to show you what that drive would look like with the drive, I say that drive, with that heatsink with the drive already mounted from Gigabyte up on Amazon. And I'll also have that information in the description. As far as the title goes, this is going to be kind of an oddity because right now it's about the Gigabyte copper heatsink, but that's not the way that's listed. 63 degrees, that's still mighty good. And the only downtime we had was while I was fiddling with getting that off of the Supermicro card and onto the motherboard. So the drive hadn't had enough complete time to completely cool down. But the results, it is what it is. Fantastic. Test is complete. We are finished. We started out with a minimum of 44 degrees, and we topped out a maximum of 66 degrees Celsius. Wow. And I believe, I didn't write it down as I'm a little bit dazed and amazed, or as the saying, dazed and confused. What were we, 58? So we're 58 degrees on the Supermicro Dual M.2 NVMe adapter, and here we are at 66 degrees on the motherboard in the second position. And remember, primary position and second position, both of these M.2 NVMe connectors are to the CPU. They're the fastest. The other two that are underneath the video card, which are under one heatsink, those two are through the chipset. Those are the slowest. And the second fastest will be anything on PCI-Express in one of these card slots that are to the CPU. And on the TRX 40, that's the way it's set up. All these slots are to the CPU. And take a look at the chart, the WD Black SN850 at 92 degrees, and in the second position on the motherboard, which is in that slot, the TRX40 Designare second heatsink stock, 65 degrees. And remember, that's with one thermal pad. With this, we have two thermal pads, and they are both Thermal Grizzly minus pad 8, meaning 8 W over MK. And we finished our second test at 66 degrees. So wrap your mind around that. I want to thank Joey for this. I got some stuff now. Let's take a look at what that drive looks like if you want to buy that heatsink already mounted. And that's the only way to purchase that heatsink. That's the Gigabyte Aorus NVMe Generation 4 M.2 PCI-Express 4.0 interface. High performance gaming. Full body copper heat spreader. And it gives you the specs on the memory. And of course, that memory is not what we're testing. So the name of this video is going to have to be the Gigabyte Aorus NVMe copper heat spreader. But I'll have a link up to this drive for those that are interested in it. Now I got another drive I want to show you, because remember, this is first generation for a 5,000 megabyte drive. We have a 7,000 megabyte drive in there. Let's see what Gigabyte is doing on their second generation 7,000 megabyte drive. And we'll also have a link up to this heatsink. That's the Gigabyte Aorus Generation 4 7,000 megabyte SSD. It's a nanocarbon coated aluminum heatsink. Now this is a third option that Gigabyte's working on. Again, for a Gigabyte Aorus Generation 4 7,000 megabytes. This is a premium M.2 2280 PCI-Express 4.0 by 4, meaning 4 lanes, NVMe, and it gives the specs on the memory. That is a heatsink, and that has 2 heat pipes. But the only way to get it is mounted to a drive. One more. If we take a look at the drives, and I want to show you this specifically because this is the second one we looked at. The heat pipe version is not available yet on Amazon. I want to point this out because if you do a search on the word temp or temperature, Gigabyte has an SSD toolbox that you can download and look at the drive just like you would everybody else's drives. Everybody's got their own toolbox, but to find it, you've got to go to the drive, the Aorus Generation 4. I'll have a link up to this. And from the top, go to Support, Windows 10 64-bit SSD Toolbox. Download it. Now, there's also a firmware update tool. You might want to check your drive and see if it needs a firmware update. And that can be done from the SSD Toolbox, or should be. Now, one more thing I want to show you, and this is under specification, right here. We had a question that was asked about these heat sinks, and this is important to know. Now on that particular drive, which is not the heatsink we tested, but on the one that's made for the heatsink for second generation, that says the temperature, it says storage, up to 85 degrees centigrade. It's important to make note of that. Of any of these drives that we look at, they should be topped out at 85 degrees. So any of the cooling situations we look at, we don't want to go above 85 degrees. It's a parameter. It tells us what we're looking at. And you also look in the specs, and they say to keep it 70% or less. That 30%, which we've always looked at as 20%, don't use it. Consider that as headroom. So when you get it 75%, consider the drive full. But 85 degrees Celsius is the top temperature you want. So when we're looking at heat sink solutions, any one of those would work. However, because heat is such a big issue, we're looking at how to address that. But as you can see how this plays out, we're addressing this on existing drives. The new drives that are coming out, which is what this kind of heatsink addresses, is about the newer drives that are going to have a heatsink. So we can see the vendors are doing something about it. I got another one to show you. Now this is a link we'll have up that'll take you into the Gigabyte SSD drive site. And you're going to see a lot of stuff that you may have never seen before. But you'll see not everything, but almost everything that got listed. The last time I looked at this, I didn't see the one for the heat pipe. I'm not going to go through it. I'm just showing you this for one specific reason. We've been asked questions about what about a cooler for an M.2 NVMe drive that's PS5 ready, heatsink with a nanocarbon fiber coating technology on it. And it's thin enough, it'll work in a PS5. And I mention that even though this doesn't say it, but that too should also fit. But I suspect, and I haven't measured, this may be just a little bit on the thicker side. Whereas this one is specified for that, and it's a little bit thinner. It's important to understand and to reiterate, this second generation drive is made specifically for PS5. This first generation copper that we've just looked at may work, but I'm not sure about the height thicknesses. We'll have to check. The point of all this is, on the higher performance drives going forward, we're going to be seeing some type of cooling solution. They're going to have to. The question is how vendors are going to address it. Now, there's another vendor that's doing some things with EKWB with another heatsink that I want to show you, but I'm going to save that for another video coming up. It's important to do it now, even though we don't have our hands on the drive, because it's EKWB, and I think it'll be a solution a lot of people are going to be looking to. We've had some questions about the drive, if somebody wants to send the drive, but we don't have it. It's not available, but we're going to tell you what we do know about it. We'll set you up with some links so you can watch it when it will become available. So I want to thank Joey for this opportunity. I appreciate it. I need to get this back now into FedEx and get it back to Joey. We got a chance to test it. If you guys have some more stuff you want us to look at or test, we got a couple of heat sinks Pablo wants us to look at. So we made arrangements. We're going to do that. And they will not fit on a quad card. They will not fit on a dual adapter, but they will work on a motherboard as long as you got clearance and no cards. So that's coming up as well. So I want to thank you for joining us. My name's Gil Boyd. This is Builder Buy. We'll look forward to seeing you next video. We're on to the next one. We're out.